Greetings, mathematicians of all ages. Today we are doing an incredibly important topic in math, and that is exponents. Exponents are probably something you're going to see, I would say, every month that you're in math class until you stop taking math classes. So you're going to see them a lot. They open up a whole new world of math, and chances are some of you have seen them before. You just didn't know what you were looking at. And today I'm going to show you that they're not that intimidating. They don't even have to worry too much. It'll be fine. All right. So first, what do they look like? All right. So exponents are these tiny little numbers that you've probably seen in books or in other math classrooms or on the board when you come back or something like that. And it's a tiny little number above another number. So first, let's just get some terminology, and I'll put two of them down here. So we have those two exponents. Try to erase my circle there. There we go. All right. Now, the bottom number in each case is called the base of an exponent. Okay. And the little number above the big number is called the exponent. You can also call it the power. Okay. So the big normal sized number is the base, and the tiny number is the exponent. Okay, it's getting really scribbly really fast. So let's look at another. How about that? So ask yourself, what's the base? What's the exponent? Clearly, the 6 is the base. It's the regular size number. The little number above there, the 3, is the exponent. All right, so let's get into what exponents are. Exponents basically are products, so we already know multiplication, products of a repeated base. Okay, so let's look at what 6 to the third actually looks like. For exponents, what you do is you take the base and you multiply it by itself the number of times that the exponent is, that the power is. Okay, so this 6 to the 6 with a little 3 would look like 6 times 6 times 6. Because I have this base, 6, and I have it 3 times, and I multiply it times itself, okay? Now, the way I read this exponent is 6 to the third power, or you can just say 6 to the third as well, okay? So let's look at another. 7 is the base, 2 is the exponent, right? So I can read this one, 7 to the second power, okay? And 7 to the second power, again, I write the base, and I multiply it by itself, however many the exponent is. So 1, 2, right? 6 to the third is 216, probably a good calculator one. 7 times 7, a good mental one, which would be 49. Let's look at a few more, just so you can think about how you'd write this. Okay, 2 to the fourth, and let's also do 5 to the third. So what I want you to do is expand those out, write them, what they look like as a repeated product of the base, and then see if you can simplify it, and see if you can do that. So pause the video, give it a shot. All right, so 2 to the fourth will look like 2 times 2 times 2 times 2, right? Because I have the base of 2, and I have to multiply it by itself 4 times. This, again, I would read it 2 to the fourth power. Down here I have 5 to the third power, and that would look like 5 times 5 times 5. And then if I simplify the top one there, 2 times 2 is 4, times 2 is 8, times 2 is 16, just kind of going in order. And then 5 times 5 times 5, likely a calculator one, and that'll get me 125, okay? Now I'm going to pause a second here just to tell you about a very dangerous thing that happens when students are calculating or simplifying exponents. Now, you may be a superiorly intellectual 6th grade student, and you may not make such silly mistakes like this, but chances are many of us will make this mistake, okay? So they see 2 to the fourth, and we know it has to deal with multiplication, and so many times, students will think 2 to the fourth is 8. And you can see all they're doing is just doing 2 times 4. And in our classroom, I usually call that a marker answer because if you give me a marker answer, which is not the correct way to do exponents, then you may have a marker flying toward your desk. Just maybe. Okay? And again, the marker answer for 5 to the third is I say, well, 5 times 3 is 15, so they write 15. And that is a marker answer. Please do not do that. Please do not do that. Okay? Now let's go backwards. I'm going to give you a repeated product, and I want you to write it as in exponential notation. Okay? So let's do 3 times 3 times 3 times 3. And also, let's do 1 times 1 a bunch of times here. Yeah, that's enough. Okay, pause the video. Try to write those as exponents. All right, so if we have 3 multiplied by itself 4 times, this is going to be 3 to the 4th power, because 3 is the repeated base, and it's multiplied by itself 4 times. Down in the second example, we have 1, 2, 3, 4, 5, 6 times, and that looks like 1 to the 6th. Now, if we do 1 times 1 times 1 times 1 times, we know that that's 1, right? In fact, 1 to the 20th is still going to be 1, right? 1 times 1 times 1 times 1. 1 to the 100th. You know, all of those are still going to be 1 as I multiply it over and over and over. Okay? All right, so the last part of the lesson, so we've been able to go kind of both directions where I give you an exponent, you expand it out as a multiplied product, and then you simplify. I've also given you the expanded product where you take that back into exponential notation. The last thing that needs to be discussed is where exponents fit into the order of operations. Now, in chapter 2, we did order of operations. You may remember that the first was parentheses, 2 was multiply and divide left to right, and the third one was add and subtract left to right. Remember, these were our gorgeous upside down triangles. Okay, but now what we actually need to do is exponents are the new number 2. Okay, so both of these actually scoot down to become my numbers 3 and 4, and exponents goes in 2. So let's just make a brand new list here. 1 is still going to be parentheses. Those always come first. Second is exponents. Okay, and then 3 will be multiply and divide left to right, and 4 will be add and subtract left to right. Okay, so as you'd guess, now we're going to have some triangles, some upside down triangles. So let's start with more basic ones, and then we'll move on from there. So first, let's do something like 3 squared minus 2 times 3. Okay? Why don't we do this one together? If I looked on my list, there are no parentheses, so next I do exponents. Just like when we did order of operations, I'm going to underline whatever I'm doing, put the answer underneath it, and write the rest. 3 squared, of course, is 9, not 6. 6 is a marker answer, right? And now as we get into our upside down triangles, sometimes we get going a little too fast. Some of you might have underlined that one. Nope. Parentheses are done, exponents are done. Next is multiplication division, right? And then I finish it up. Okay, let's do another. Let's do 2 times 4 plus 2 to the 4th. Let's try that one. Why don't you pause? Give it a shot. All right, on this one, once again, no parentheses. So why don't we go ahead and do the exponents first, underline there. 2 times 4 plus, remember this expanded out would be 2 times 2 times 2 times 2, right? Oh, that looks like a 1. Squish it in there. There we go. Which is 16, right? And now our multiplication would come next. And then finally my addition. Okay, why don't we get some parentheses into the mix here? Let's do 3 plus 4 times 3 to the third. All right, give it a shot. Okay, and this one we do have parentheses, so I got to start with those. Rewrite the rest. Next would be exponents. 7 times. Don't put 9. That's a marker answer. So now we have 3 times 3 times 3 as I'm just thinking about it. That is 27. Probably a good calculator option here. 7 times 27 is 140, 189, right? Okay, let's do 2 more. All right, let's make it a little trickier here. Let's do 8 minus 4 to the second. And you almost heard me say squared. Anytime something is to the second power, you can say that something squared. So like that, you can read 7 squared or 5 squared. And then something to the third, you can read something like 4 cubed or 2 cubed. Okay, so let's get rid of those. Anyway, back to our example here. And then let's do 3 times 4. All right, give it a shot. Pause. All right, back at it. You may think that this 4 squared has to happen first, but as we know, all parentheses happen first. So I actually do what's inside the parentheses, 8 minus 4, and I write the squared above whatever that's simplified to, right? And now I do my parentheses. 4 to the second is not 8, it is 16, because that's 4 times 4. Next would be my multiplication. And finally, that addition, right? So you're going to have some nice upside down triangles here. Let's do one last problem here. Let's do 3 times 4. Let's make it nice and long. 4 plus 3 minus 2 to the third. Give it a shot. Pause it. Go. All right, we got some parentheses. We got to take care of those first. Next, we have an exponent. Rewrite the rest. Next, my multiplication. And we finish it up, right? All right, so incredibly important exponents. And we gotta make sure the biggest thing, if you can get anything out of today, is that this is not 6. It is not 6. You gotta constantly think of how do I expand exponents out to a product of repeated bases, and we'll be well on our way to getting to the tougher topics that use exponents. All right, see you next time.